Hello everyone, welcome to this video. So in this today's video, we'll be solving the problem min cost climbing stairs. It's an easy level problem and it's a problem of the day on Leetcode. So you are given an integer array cost where cost of I is the cost of ith step on a staircase. Once you pay the cost, you can either climb one or two steps. That's a very simple and pretty straightforward statement. So you will be entering on a step once you pay it, and once you pay the step, once you pay the cost for it, you can go climb one step or two steps from that particular step. So you can either start from the step with index 0 or step with index 1. This is also the freedom that has been given to us. There are two properties that has been given. You can either start from the step with index 0 or step with index 1. Okay, so that is the starting investment that you can make either by putting your leg on index 0 or index 1. If you put your leg on index 0, that means you definitely need to pay index 0 step cost. And if you're putting your leg on index 1 step, you definitely need to pay for it. Okay, that's how you need to do. So return the minimum cost to reach the top of the floor. That is the question. All right, so your decision must be in such a way that you need to return the cost. You need to decide the pattern in such a way that you only pay minimum amount of cost. All right, so that is the question. So these are the examples that have been given. We will see that on the notepad. So, and also you can see the code to the right side. It's a very simple code. We are using the concepts of dynamic programming. Like we are using the previous results, we are storing it, and we are using it for the current results, and but without taking any extra space. The reason being, we are updating the array that has been given to us instead of taking a new array. All right, we are changing the definition of the array that has been given to us. In this particular array cost, this particular elements like cost of I denotes the cost of that particular index, cost of that particular index step. All right, cost of I denotes the cost of the ith step, but we'll update it such a manner that cost of I tells the cost required to reach that particular ith step. All right, so it will be taking all the costs that have been used to reach that particular step. That's how we'll be updating the cost array. So how are we doing it and why are we doing it? We'll see it in brief now. So this is the first example given, cost equal to 10, 15, 20. All right, so like the very first decision. Okay, there are two decisions, two things. First thing, you can choose between zeroth index and first index. Okay, this is the first choice that we need to make. Second thing, whatever the choice that we need to make, choose to climb one step or two steps from that, one steps or two step from current step. So these are the two decisions that we need to take. All right, these are the two decisions that we need to take. So very first thing is this. So how are you going to decide? So some might be saying that I'll be choosing the minimum among these two. All right, I might be choosing the minimum among these two. So what is the minimum among 10 and 15? Minimum among 10 and 15 is 10. So and then proceeding further. So what if I choose 10? Let us assume I have chosen 10. Then I have the freedom of going to climbing one step or two steps. So I'll be climbing two steps. And now when I enter this, I need to pay 20. Okay, so and then what is the extra cost now that I have got? 20. So 10 plus 20, which is equal to 30. All right, this is 10 plus 20, this is equal to 30. And now I can climb one step and I can go to the end. This is the end. Okay, end is the point after the array, after the thing. So what is the total cost I've got? 30. But what if I've chosen 15? What if I've chosen this particular 15? Okay, what if I chosen 15? So 15 is my initial cost. This is my initial cost. Okay, this is my initial cost first. Then plus after that I'll climb two steps. Directly I'll come to the end. Okay, so what is the total cost I've got? Just 15. That's it. I'm done. So what is the minimum among these two? 15. So my decision should be in such a manner that I get the best output. It's not that at that particular instant what is the minimum that I'll be choosing. No, that's not how things work. All right, so I hope people got an understanding. So let us even dry run the second example. All right, so instead of dry running the second example, we'll understand so what must be our approach. Okay, and we'll apply that approach on the second step. So why did I choose so how can I get the intuition that I need to choose 10 I need to choose 15 instead of 10? So how can I come to that conclusion? So remember, our if like it's been, everything has been given to us, every cost of the ith step has been given to us, so and we can choose anything between these two initially. Okay, anything between these two initially. So what I'll be doing is, I'll be going to each and every step from the second index. Okay, I'll be going to each and every index from the second index, and I'll be calculating the cost. Okay, I'll be calculating the cost associated in reaching the ith step. Okay, ith step. Okay, so this is basically nothing but cost of ith step plus cost, so plus minimum of cost in reaching I minus 1 step and cost in reaching I minus second step. Okay, so this is what I'll be doing. So I'll be calculating cost associated in reaching every ith step from second index, and what would that be? That is basically nothing but the cost of that particular ith step, and minimum of cost in reaching a I minus 1 and I minus 2, because from I minus 1 I can do one step climb, and I can come to ith step, and from I minus 2 I can do two steps climb, and I can come to I step. So I need to decide what is the minimum cost of these two, so that I will add that particular minimum cost to my cost of ith step. Then I'll be getting the best cost. Okay, the best cost in reaching the ith step. So let us do the same experiment for 20. So for 20 there are two choices. Okay, there are two choices, 0 index and first index. So I can even come from 0 index, I can even come from first index. So what will I choose? I'll be choosing 0th index, because the cost associated for reaching 0th index is minimum, right? The cost associated for reaching first index is 15, but for second index it's 10. So for 20 I'll be choosing 10. So what is the best cost in reaching 20? That is 20 plus 10 equal to 30. So this is the best cost. Okay, best cost in reaching 20. All right, now I'll be seeing the so I have got the best cost associated for each and every element in the array, but I need to work out on the end position, right? This is the end position, I need to work out for it. So what are the favorable positions that I need to do? Same thing, I need to work on the last bit before one and last one. These are the two steps. From this I can do two steps climbing to get the end, and from this I can do the one step climbing to get this end. So I'll be taking the minimum of these two costs, minimum of the last two elements. So what is the minimum of the last two elements? This is 15 only, but this is 30, because what are we updating our cost array to? Cost array is basically now nothing but the cost associated in reaching the best cost associated in reaching the particular ith step. So here 20, for reaching this particular step we need to spend 30, but for this only 15. So what is the best among these two? 15. So that is the reason 15 is the answer. So now let us do the same experiment. Okay, let us do the same experiment, write down this experiment on the second example, so that people will get an extra clarity. So okay, I'll write these things here itself. So okay, what is the best cost in reaching 0th index? So what is the best cost in reaching 0th index? That's basically this itself, right? This itself. So that is 1. So what is the best cost in reaching first index? So first index. So there are two possibilities. Either come to 0th index and then jump one step so that you get first index. But in doing so, I'm adding the cost of 0th index. So it's better I don't do it, rather directly jump to first index itself. So that is 100. So I'm updating the array. This is the new updated array, 100. I'm writing it here, and these are indexes: first index, second, third, fourth, fifth, sixth, seventh, eighth, 9th. Okay, so these are the index, and this is the updated cost array. Okay, updated cost array. And what is the best cost in reaching second index? What is the best cost in reaching second index? What is the second index element cost? 1 plus minimum of last two. What is minimum of last two? That is 1, 100. So that is 2. All right, so this would be 2. Reason being, from 0th index I can climb 2 steps to get to second index. So what is the total cost that I need to pay? 1 plus 1, that is 2. That's it. But what if you are coming from first index? You need to pay 100 plus 1, that is 101. So that's not a best cost. And now come to the third index. So what is, I am writing BS, best BC, best cost in reaching So second index is done, third index. What is best cost in reaching third index? Third index step, that is 1. So third index cost 1 plus minimum of last 2. So first and second, what is minimum of 102? So that is 2. So this is basically 3. Alright. So this is 3. And now come to the fourth step, fourth index, BC in best cost in reaching fourth index. So what is that? So what is fourth index cost? That is 1 plus minimum of last 2, that is 2 comma, so 2 and 3, so 2 comma 3, that is 2, so 3. So this is the best cost. So best cost in reaching fourth index is 3. You can directly jump from 0th index to first index, and then from 0th index to second index, and second index to fourth index. So this is how you can directly reach it. Now come to fifth. Okay, what is the best cost in reaching fifth index? So that is basically fifth index cost, that is 100 plus minimum of the last two steps, best cost in reaching the last two steps. What's the best cost of reaching third index? 3, and fourth index 3. So both of them are 3. So this is 103. So this is the 103. 103 is the best cost in reaching the fifth step. So I'll erase these elements now. Okay. So now come to this. So what is the best cost in reaching fifth index is done. Sixth index. What is the best cost in reaching sixth index? Sixth index cost, that is 1, and minimum of last 2, that is fifth and fourth, that is 3 comma 103. So that's basically 3. So it's 4. So this is the best cost. 4 is the best cost in reaching the sixth index. Now come to the seventh index. Best cost in reaching seventh index. Okay, seventh index is basically seventh index cost, that is 1 plus minimum of last 2. So that is fifth and sixth. Minimum of 103 comma 4, that is 4 plus 1, that is 5. So this is the minimum cost in best cost in reaching the seventh index. Okay, I'll even need to erase this now. I'll take this. Okay, sorry for this inconvenience, guys. I'll just take this element up. Okay. Okay, now seventh index is done. So what is the best cost in reaching eighth index? What's the best cost in reaching eighth index? Eighth index cost, what is eighth index cost? 100 plus minimum of best cost in reaching the last 2, that is seventh and sixth, that is 5 comma 4. So 4 is the best, so 104. So 104 is the best cost. 104 is the best cost in reaching the eighth index. And finally the last one, best cost in reaching ninth index. That's basically ninth index cost, that is 1 plus minimum of last 2, that is 5 comma 104. So that is 5. So total 6. So this is the 6 is the minimum. So 6 is the answer. I hope you people understood. So basically now we have calculated the best cost of reaching all these steps. Now last 2 minimum. Okay, last 2 minimum would be the answer. 104 and 6. What's the minimum among these? 6. 6 is the answer, because we need to, this is the end position, right? So end position can be reached from 8th index by climbing 2 steps, 9th index by climbing 1 step. So I'll be choosing the best cost associated with these two, and like the minimum of the best cost associated with these two. So from 8th index, if I need to jump to 2 steps, I need to spend 104. But for 9th index, I just need to spend 6 coins, so that I'll come to 9th index, and then I'll just climb 1 step. I'll be getting to the answer. That's it. So this is how you need to do. So this is the code, very simple code. So for int I equal to 2, I less than cost dot size I plus plus, I am updating my cost array. So before cost array indicates, like before this iteration, cost of I indicates the cost of that ith step. But now we are updating the cost array to cost of I denotes now cost of I denotes that the cost associated in reaching with that ith step. All right, so this is how we are updating. So cost of I depends upon the last 2 steps, and after this we'll be returning the minimum of last element and last second element. So these two, the minimum of these two would be the final answer. I hope you people understood. So this is the C++ code. Java, Python, C++ code has been uploaded in the GitHub repo, and that link has been given in the description. You people can check it out. So if there are any doubts, feel free to comment in the comment section, and also we can just submit the code for your reference. And the time complexity associated here is TC is O of n, just a single iteration we are doing, and SC O of 1. Okay, because there is no extra space that we are taking, that we are updating the array that has been given to us. That's it. So That's it for today. So it's a very easy question. We are using the concepts of dynamic programming without taking an extra space. That is the only speciality here. So if there are any doubts, please feel free to comment in the comment section. Thank you for watching. Stay tuned.